Wow, my mouse is so tiny.
Well, that DPI.
Yeah. Yeah, this TV is pretty crazy. It's like a touch screen. All right, I'm just gonna go ahead and get started. I think we're good. Thank you everyone for coming. So this talk is the future is extensible, leveraging llms and wasm for customizable software. So I use llms for this title, obviously. And you can tell a lot of other people did too, because I think the next talk is also uses leveraging. And then I saw some in there that were like delving into stuff. It's like,
I use it for mine.
yeah, which maybe that's just what we do now. I don't know. It's just like,
This is what happens when AI writes your titles.
exactly. It's just going to write talk titles from now on. So a little bit about me. I'm co-founder, CTO of a company called Libso. Worked at a few places around. I've been doing this for roughly 20 years, so I've been working in a few different places on and off. Live here in New Orleans. Been here on and off my whole life, and just around Louisiana. But if you don't know me, come talk to me. Pretty friendly person. So, what is this talking to me about? Quick outline. We're going to talk about what is extensible software. I feel like this is kind of it's going to be good. It's going to be really important for us to like have a pretty. It's going to be important for us to have the same definition that I have about what extensible software is. It's kind of a muddy term, so we're going to kind of harden that. We're going to talk about why software isn't extensible anymore, and you're going to kind of notice why that is the case, and we're going to kind of go and dig into why, and we're going to talk about the forces that are changing how that problem and where things are going. I'm going to demo like a potential future that I think is coming out of this. So let's start with the definition. For me, a good definition would be, as an end user, I can change the behavior of the application with some language, but without changing the core structure. So that second part is kind of important. What I'm getting at there is like, if you think like open source software is extensible, I'm saying like, that's an argument that you can make, but that's not really what I'm interested in. What I'm interested in is like, as a user, I can change the software without changing the core structure, without forking it and recompiling it. The extensibility needs to be built into the software like as a product, like as part of the product. So just like the simplest example I could think of would be like something like dark mode, right? Like dark mode or light mode, right? So you could think of this like we're giving the user a language of a Boolean to tell us how to customize a feature, like the theme, either dark or light. You could make this a little bit more extensible with something like a color picker, right? Like you now, instead of having a Boolean, you have now like a hex string or something, and you can change the color of the background or something like that. So you might be seeing is kind of this idea like, you might be seeing a pattern here where there's maybe not like, extensibility is maybe not like a binary thing. Like there's some like degree of extensibility here. I think a good mental sort of formula you could use would be the expressiveness of the language and the product of that and sort of the percent of features that are customizable, right? So here our language of a Boolean is not very expressible. A hex string is more expressible, so it's like more extensible. And then you could also think like, maybe we allow you to change the color of like multiple buttons and stuff, so that would make it more extensible. So it's kind of these two variables together. So what I think is sort of the holy grail of this is what we call a plugin system. So a plugin system is like you have the full expressiveness of a Turing-complete language, right? You get a whole programming language to describe your customization. And it also generally has a lot of points in which you can sort of hook into the application. So it's a high degree of extensibility. Here's an example of a Minecraft plugin. And some things to note, like you'll see, it's basically just a code module. In this case, it's like a Java class. And it exports these like event handlers. So it basically says like Minecraft can kind of call these functions. It can call like on enable. It can call player join. It can call update tab. And in turn, the plugin itself can call functions in Minecraft, right? You can call this like tab API functions, and so it's almost like it's like part of Minecraft, but it ships separately on top of Minecraft, right? But it has like all the power of the code of Minecraft, and you have a full Turing complete language to describe things. So it's highly customizable, right? So here's an example of what you could do with something like this. Like this is a Minecraft plugin called World Edit. And I don't actually play Minecraft, but this is just a great example. So in Minecraft, you can go around with your little hand tools and build out a world. Like with World Edit plugin, you can like script and sort of terraform whole planets, right? And what's cool about this is like a plugin developer who doesn't work for Minecraft or anything. Like they were able to come up with their own tools and build this, and Minecraft didn't even have to think about it or build it or anything. It's just kind of it's something they allow their users to build on top. Another obvious example that people have to interact with every day are your browser extensions. So this is a Chrome extension called Grammarly for a service called Grammarly. And what's really interesting about this is so it's like running in real time in the browser, but it's also like customizing Google Docs. So it's like really crazy to think about like how much, there's no way like when they created Chrome, they were thinking like this grammar service is going to use it to customize this like Google Docs thing. Like there's so much going on here that's really just flexible about the way that Chrome is built. So what about the web? So these are like desktop applications. What's going on with the web? Like a lot of us are web developers, right? There are not many examples of this on the web. The best example I can think of is something called Salesforce. If you've never heard of this, it's basically a customer relationship manager. It's a CRM, and it's fully programmable in that you can push code into it, and like it can call that code when things happen. So it has like basically a plugin system in it. And they have their own language called Apex, and it's really powerful, but also really much maligned amongst the programming community. Another example I would say, is something called Cloudflare Workers, which I think a lot of people look at it as sort of like a serverless function infrastructure, but actually I look at it like it's a plugin system on top of their CDN, right? So you have a CDN system, it's scriptable. They've created a programmable CDN. Whereas Salesforce has created a programmable CRM. But where's the programmable everything else, right? Like why isn't there programmable everything? So what do we have today to like make software extensible? We have these kind of low resolution tools. All we really have are APIs and webhooks. And I kind of look at these as like, it's sort of like a decoupled plugin system. Like your sort of events are like webhooks, and your sort of APIs, your capabilities are like your HTTP API, and you kind of just like move the plugin off onto like the customer's server, and you sort of talk to it over a network, and it's just kind of this decoupled thing, right? But you could imagine like especially this event part, right? Like you can only really do asynchronous stuff with this. Like it's really only just a good way to move data around. Like you can imagine you can't really build something very real time. Like if you look at this video, every time she's typing and clicking, like the plugin is like doing something, right? Like, and it's responding to her. And you couldn't really easily do that in a system like this because it might be separated by an ocean, and there's networks and they fail. So this is very limited. So there's two barriers, I think, to implementing a plugin system in recent history. First is the market size of customers with developer hours. And second would be the cost to implement a secure execution environment and developer experience. So let's talk about the first one. If you're kind of new to programming, like not too long ago, it used to be very rare to have developers on staff. Like nowadays, like if you have a marketing company, you probably have some developers around. It used to be only really software companies had developers. And thus, to make software that needed to be customized with other software was extremely, like marketing, it was extremely limiting option, right? You could have a much smaller market size of customers who actually have developers who can customize the thing. So what started happening was like low code and then no code platforms. So something called Zapier, and they're kind of they sort of are the leaders of this no code movement, and they say like no code is the future of business, right? Because they have a lot more customers who they can use to customize things, and having less code is better in that sense. But you'll see that even they're kind of starting to say like, okay, like we need code now, right? So what are we moving to, like some code platforms? Are we going back to low code platforms? Like they're all kind of starting to give in to like, we need code now. So what's going on? Like it's crazy because if you talk to a lot of these customers, like I've talked to a lot of these companies, and they're like cults, like they program them. If you say something about code, they're like, no code, we don't need code. So it's like really built into the culture of these companies. So this is a big deal that they're like, we need code now. So I think one of the things that's going on is really just the number of developers that are out there in the world. Like I said, it's now very common for like pretty much every company to be online and to have some developers or to have some contracting staff of developers. Development hours is like something that's coming a lot more freely. I think it's going to continue to grow. I think this is an underestimation of where it's going. Also, I think like there's a kind of a gray area between like developers and then like people who know how to code. I think the people who know how to code box is like going to go even bigger. And the main reason is really, I think, LLMs, because they make coding more accessible. I think like I'm probably on the more conservative side about how good LLMs are going to get. But even if you look at just where we are today, they already make learning coding so much easier. Like, I don't know why people ask for help from anyone. You go talk to the machine. It tells you exactly what you did wrong. It'll tell you how to fix it. Like, it's amazing. And if I had that, like, I would have learned so much faster. And I want to point out, like, you know, there's like kind of a lot of like doomer opinions about like LLMs are going to make coding like obsolete or whatever. I think it's going to be the opposite, because when you just look back in history, every time we made something easier and more relevant, more people do it, not less. And this is just kind of some examples of things that have happened over time with programming that made programming more accessible, or programming, so like Node.js like made programming servers more accessible to like kind of front-end developers. Like it actually grows the pie, right? And I think now LLMs are going to be a huge change there. So another thing about this, I think, like I also put MySpace on here because that might seem kind of weird, but I also think that another big thing is like MySpace, stuff like MySpace is really underrated in terms of growing the number of engineers, because it was one of the first times that like it really gave people a good reason to code, like young people, like because there was no sense of like, hey, you need to learn this thing because it's going to give you a good career, and you're like 15 years old, like I don't care, like I want to get girls on my MySpace page or something. Or it's like, you know, this code is like so powerful and you can do all this stuff with it, like you don't care, but you care about customizing your MySpace page, and it just happens to be that you have some CSS and HTML to do that. And then a bunch of people started doing it and they realized like, oh, this is actually really powerful, I can do anything with this, and oh, actually I understand it, like I changed this variable and like I can code, like I have this power, and it kind of brought people further and further down the rabbit hole. I think we need more things like that, but yeah, I think like LLMs are gonna kind of like enable a bunch of people to get more curious and also to like learn more. I also think that LLMs are really good. They have the ability to translate between languages really well. And like, what's the perfect language for computers? It's code, right? So I want to translate requirements. I want to translate what I want to do into something computational. I think emitting code is kind of the perfect way to do that. So that kind of takes care of like the sort of market thing. Like I think the number of people who kind of know how to code a little bit is going to grow, and that's going to take care of that. The other side is like the cost of building this stuff is very high. So what do I mean by that? So this is kind of a brief overview of like sort of where compute has lived over the past 80 years or so. So initially, like back in the day, it was kind of like cloud computing. Like everyone had these big computers and you would all sort of timeshare into it, and you would all share the compute on the server. And then back around, I think the 90s or so, once desktops came out, like there was the desktop era and all the compute went back to the client, right? So when I grew up, all of my software had plug-in systems or was extensible. Like even the software that wasn't meant to be extended, we extended it. Like you would get games and you would mod them. Everything was extendable with code. And what happened was like when we went back to the web, or when the web happened, we basically moved the interesting compute back to the web. So what the consequence of that is really like the the liability of when something went wrong also went back to like the server. So back in the day, like I downloaded a like plugin for Windows that would turn my mouse cursor into a Les Paul, and it would like make noise when I click stuff. And there was a virus in it, of course, and I had to go to like Circuit City with my parents, and like they had to remove the virus, and it was really embarrassing. But that was the worst outcome, right? Whereas like now, like if I'm Salesforce and someone installs the equivalent of the like guitar cursor in Salesforce servers, like they're taking a trip to the FBI. Like their company may go under, their customers may go under. It's a really big deal, right? So the liability shifted back to like we have these secure environments where everyone's code is being run on the same machine, and the cost of that being exploited is too high. So what I think has changed here is a technology called WebAssembly, which I'm not going to go too into like a bunch of details about why, but here are some reasons why it's really cool. But WebAssembly is this new technology that is perfect for running untrusted code. So it's perfect for running these third-party plugins in a safe way and protecting the application from that plugin or that code doing something bad. So if Windows was using like WebAssembly for the mouse and cursor customization thing, and like they shipped a vulnerability, like it would have not affected Windows in that case. Going a little bit deeper into WebAssembly, like you might think, so WebAssembly is like a browser thing, right? Like how is that going to be run on the server? How does that affect the rest of my software? Well, there are lots of ways to run WebAssembly now outside of the browser. There's these kind of standalone runtimes like Whammer, Wasmer, and you can just kind of throw a WebAssembly module at it and it runs it, or you can embed it via FFI in your application. There's what I call language native runtimes. So if you use Node.js or Cloudflare Workers or anything like that, there is a WebAssembly runtime like already in there, like native to the language. There's runtimes like Wa0 and one I created called Chicory for the JVM. But these are all like pretty low level details. Like if you're just kind of interested in like experimenting with this, I would say look at my company's open source project extensible. And what this does is this basically, it doesn't matter what language your app is written in. Right now we support roughly 16 languages, probably more. But if you have like a Ruby application, you want to run a plugin, it just is going to look like a Ruby function to you. So we basically hide all this stuff so that it just feels like calling a function in your native language. And we also support at least 11 languages that you can compile a plugin into. So what does all this look like put together? So this kind of comes to a product I'm working on called XTP, and this is sort of like all this sort of plug-in stuff like in a box. So I have a web application. I want to have extensibility via plugins. This is a platform that gives you all of that stuff, and it's built on extensible. So what we're going to do is we're going to do a little demo. So earlier I talked about like Salesforce being a good example. And so like, I think a good example would be to take this CRM, another CRM, it's an open source CRM called 20, and this CRM has like the ability to customize data fields like Salesforce, but it doesn't have the ability to customize logic like Salesforce. So I'm going to add XTP to 20 to give it the same power as Salesforce. The way that Salesforce works, the most interesting kind of part about Salesforce is this idea of triggers. And triggers are basically anytime you update an object in Salesforce, it's kind of like they'll wrap around all these CRUD operations and they'll call your code when some event happens on an object in Salesforce. And with this kind of programming model, like you can customize anything in Salesforce. So how are we going to do this in 20? So earlier on, I talked a little bit about like APIs and webhooks being kind of a deconstructed plugin. The easiest way to do this is to basically just bring it back in, right? So I'm just going to bring that customer logic back into my application. And I've already defined the interfaces already have the interfaces and the code defined, right? Except the only difference is that I'm reaching out over a network. But what if I could just bring it in? I have the same interfaces, but it's just a function call. It's just right there. So that's kind of what we're going to do. In order to get events, I basically, so Salesforce triggers it. This is kind of like an ORM middleware, like you're sort of just hooking into when objects change. So I went in and just hooked into 20's ORM layer, and we basically have our little wasm sandbox here running in process, and it can call the customer code anytime someone tries to change something in the ORM. For the interface, we have this thing called an XTP schema, and this is kind of like OpenAPI. So I was actually able to take 20's OpenAPI definitions and just dump it in XTP, and it already knows about the interfaces between these things, right? Because they've already defined these. So this is a way to kind of bootstrap a plugin system. So I'm going to do a demo. I'm going to do it on video because don't really have good enough network to do this, and it probably going to take a while if I do this network. But this is 20, and so it's a CRM. So there's lots of like built-in data structures for like companies and customers and people. So it's a way to manage your customers and your sales processes, and you can customize all these objects as well as like create custom objects like rockets or whatever you want. So you can fully customize the data layer, but you can't customize the logic layer, right? So that's what we added. So I'm going to look specifically at this task thing, and we're going to build some custom logic for task. So tasks are these they're just objects in 20, but you have this Kanban style view, and you can create tasks and you can move them around. So we're going to kind of come up with some requirements for what should happen at our company when people move tasks around. So I'm going to jump over to the terminal, and the first thing I'm going to do is I'm going to create a plugin that goes into 20, and I use my XTP command to do this. And we support a variety of languages right now. We'll be supporting some more soon. I'm going to choose TypeScript, and it's going to basically generate the scaffolding out for a plugin for me to have some custom code here. So I'm going to go into that. I'm going to open up an editor here, and we're going to go into the kind of bootstrap part. And right now I'm just kind of focused on tasks, so you only see these two, but I basically have like a before and an after on the update part of this task. So you would imagine there would be like, we could have different functions that allow you to hook into different things. Like you could have before create task, or before delete task, or after delete task. But I'm just kind of interested in the task update, and exporting these functions to the application is a way of saying like, I'm interested in getting events about this task update, right? So we generate all this like code for you, and we generate all the bindings. So I'm going to write a plugin really quick. What this is going to do is this is going to just, when someone tries to change the tasks to done, we're going to throw an error. And what's kind of interesting about this is like, this is something you can't really do with APIs, right? Like we're actually like validating the object before it goes into the database, because if your plugin exists on the other side of the network, like it's never going to make it in time. So it's really cool that you can kind of hook right into it. This runs in a few milliseconds, and it runs reliably 100% of the time. But yeah, instead of doing this and pushing this, I want to show this other sort of feature I built for this demo. So it's a prompt. So what I'm going to do is I mentioned earlier that LLMs will be good for like building these features. So I'm going to basically I have an agent that is able to take requirements and just build features for us and push them right into the app. So I'm starting my XTP agent prompt here, and I'm going to prompt some requirements. And for our requirements, I'm going to say when a user changes the status to done, it should assign to their manager, and the manager email is tim@apple.dev. So what this is going to do is it's going to generate the code, it's going to compile it, it's going to push it right into 20. And so let's look at what the code generated. And what's really cool about this is it actually so 20 doesn't have a way to assign a task by email. So it actually figured out I need to go call a function inside of 20 to find the ID for that manager. So it says I have an email, I'm going to go find that manager, I'm going to get their ID, and then I'm going to assign the task to that ID. So it's actually able to sort of figure out how 20 works and talk to it and get done what it needs to get done. So it's done that. So this is a function that we're importing from the application that we can call that you can use to find workspace members, which is kind of like find people in your company that are signed up to 20. So this already sort of built this and compiled it and pushed it up. So we'll jump over to the app. So without having to redeploy the app or anything, I can just go change it, and you'll see, boom, it figured it out. It's running my code in there, right? And it might have looked like that kind of fell in. It's actually happening synchronously, but 20 uses some fancy UI stuff where they progressively update it. But it happens synchronously. It happens when you update the object. Okay, great. So let's make it more complicated. Let's suppose that Tim at apple.dev can only handle one task, though. He's really busy. If he has tasks, let's assign to johnny.ive at apple.dev. 20 has this Apple themed stuff for their examples. So we're going to generate some more code here. We'll take a look at the code. So now it was able to figure out okay, I need to now figure out how many tasks Tim has. So I'm going to use 20's function find many tasks. I'm going to call that function and figure it out. But I noticed that it actually made a mistake here. It shouldn't check to see if it's done. So I have another version of this agent where when there's ambiguities, it asks you hey, what do I do for this? But to make it faster, I just told it, just guess. But the production version will ask you for clarifying questions about edge cases and stuff like that. So fixed that problem, pushed it up. And now, so Tim already has a task. So if I create a new task and I push it over, it should assign it to Johnny. And figured it out. I did it. So that's cool. So one of the other things I talked about, right, was this is also a good way to, it's not just a cool way to customize software with software, but it's also a good way to push AI into applications. So this is a little bit meta, but we're going to ask the AI to push an agent into the application. So now what we're going to do, we're going to change the requirements. When a user moves a task to done, let's use Claude to classify the task based on its title, and it should determine if it's a sales related and assigned to Tim at apple.dev, and if it's engineering related, assigned to johnny.ive at apple.dev. So what we're actually doing is we're actually pushing kind of some code and a model. So we're also, another interesting thing is this code doesn't have test. I just paused it, but this code doesn't have test, but if it fails to compile or do anything, it just tells Claude this is, I messed up. Well, I'm using Claude, this agent also uses Claude, but the agent is able to read the errors and then fix it and then recompile it. So it just kind of has a loop where it will keep going until it works and then push it up there. So it made a mistake and fixed it and pushed it up. So let's look at the code. So now it's using Claude to create a prompt, a classification prompt. But I noticed that it kind of made a mistake. Basically, there's no system prompt here. So what happens is sometimes when there's if you don't have a very good model or a good prompt, like, and you try and do some kind of classification task or something programmatic where you want it to have a certain response, it'll give too much context. So I basically said, you should probably use a system prompt, or else it's going to give too much context and fail to sort of parse the response. So there's still a little bit of domain knowledge leaking through here, but probably if I had a better model, it wouldn't have done that. But it said, okay, yeah, no problem, I'll fix that. So now when I create a task and move it over, it should say, this is a pricing call with company, so it's Tim. And then I'm going to say, there's a bug in the UX, so that should assign to Johnny when I move it over. So yeah, it's determined as engineering related, so it goes to Johnny. So that's it. Any questions?